This video is from section 4.9 and it's on solving quadratic inequalities. And you probably watched the video on graphing quadratic inequalities, and solving quadratic inequalities is very similar, although it's as if you're going to take a piece of the graph that you graphed and shaded, and you only want to look at the x values that are going to make the quadratic inequality true. So these are the steps, and go ahead and pause the video and jot these down. But the first step is to get the equation in standard form. So if you don't have everything on one side, of course, and with 0 on the opposite side, you'll want to start with that. Step 2 is to solve the quadratic inequality to find the solutions of the equation. And I'm going to highlight equation here because obviously up here, it's an inequality, so you're just going to pretend for a second that that inequality is actually an equal sign and just go ahead and solve that quadratic. So remember, when you solve a quadratic, you want to maybe factor it, use the quadratic formula, complete the square, solve by square roots. You have all sorts of options. Then step 3 is to test some points to find out the solutions of the inequality. So once you have the solutions to the equation, it's really not an equation. So you want to test points to either side of the solutions that you've received to see if it's greater than those answers or less than those answers to make that inequality true. So we will walk through these 3 steps. All right, so first step says solve a quadratic inequality algebraically. So you have x squared plus x is greater than or equal to 12. So again, your first step is you want to get everything to one side so that it's in standard form. And I like to keep my x squares positive, although that's up to you. So I'm going to subtract 12 to make that greater than or equal to 0. That's the first step. Second step is you want to solve this. So just kind of ignore the inequality and you want to solve this. So maybe it's factorable. If not, I would probably use the quadratic formula. Lucky for us, I can tell that it's factorable already. So factors of 12, negative 12, excuse me, that add up to a positive 1x. So that would be plus 4 and minus 3. Then you solve these, even though it's an inequality. So for just a second, I'm going to ignore that inequality and set those factors equal to 0. So x equals negative 4 and positive 3. Now, important to understand that if I put 3 up here into the equation, 3 squared is 9, 9 plus 3 is 12, and 12 is greater than or equal to 12. Yes, it is. It's equal to. Negative 4 squared, 16, minus 4 is 12, and yes, 12 is equal to 12. So yes, these work, but it only is the equal to 12 and not the greater than or equal to 12. So what I would do, and this is optional, but I would visualize these on a number line. So let's say this is negative 4, and there's 0, 1, 2, 3. Okay, so you are either going to say anything less than negative 4 is going to work up here, or everything greater than negative 4 is going to work, everything greater than 3 or less than 3. So you've got some testing of points to do is basically what this is going to amount to. So I would test 0 because that's a really easy point to test. And, test it wherever. I'm going to test it in my original because I know that my original equation is not going to give me, I didn't mess up my original equation. So if I put 0 in there, 0 squared plus 0 is greater than or equal to 12, and is 0 greater than or equal to 12, and no, it's not. So I don't want my inequality answer to go anywhere near 0. So in other words, I have to be greater than 3, because if I were less than 3, I'd capture 0. I have to be less than or equal to negative 4, because if I were greater than that, I'd capture 0. So really, with that one point and not alone, I have my answer. So I know that x has to be greater than or equal to 3, or x has to be less than or equal to negative 4. So if I finish this, you do not have to do a number line, by the way, but I know it's going to look like this and look like this, so going opposite directions. If 0 had worked, made a true statement, then I know it would be everything in between negative 4 and positive 3. So it would be an and statement. So bottom line is this right here is your answer. And I will tell you this, more often than not, I get people stop at this step. They'll solve for it, but they'll forget they're dealing with an inequality and not an equation. So be real careful with that. By the way, if you graphed this, and I promise you this, you don't have to graph it, but if you did, it'd be a parabola opening up, and it, would look something like this, and it would be shaded everything greater than, so everything to the outside. So look at that. That's where my arrows are pointing, right? And that's where I would be shading. So really, a graph gives you the solutions that will make X work. So if you wanted to graph it, you could certainly do that. But really, you're just kind of finding these pivotal points right here, and then deciding if it's everything in between them, which would be shaded in between, or everything on the outskirts. All right, one more quick one. So pause the video, try this one on your own, and I'll go through this a little bit more quickly. So first step, again, is to get everything on one side. So I like to keep my x squared positive, so I'm going to bring everything to the right-hand side. So I'm going to have a positive 2x squared, a minus 12x, and a plus 16. Had you not done the same thing as I did, then you would be dividing everything by a negative, and then please remember you'd be flipping that inequality. So just be really careful with that. Now I'm going to go ahead, everything is, divisible by 2, so I'm just going to cut everything in half to make my life a little bit easier. And again, if you didn't catch that, it wouldn't be the end of the world. You would just have a little more thought process. And again, everything is factorable there, so it's going to be x minus 4 and x minus 2. Then you set the factors equal to 0, and your pivotal points are going to be a positive 4 and a positive 2. So on a number line, I know that it's either going to be everything in between 2 and 4 or everything going opposite directions of 2 and 4. So again, I would test 0 since it's not a solution, and that's the easiest point to test. So if I put 0 in for all of the x's, and I think you could probably do the mental math here, everything wipes out on the left-hand side. And is 0 greater than or equal to 16? No, it's not. So I want to not make an inequality that would include 0. So it has to be greater than 2 and less than or equal to 4. If you're unsure, test more points. Try testing 5. Put 5 in here, and it should make a false statement. So then it's everything less than 4, but greater than or equal to 2. So when you write this, since it's an in-betweener, you can write x in between, so less than or equal to 4, yet greater than or equal to 2. If you write this as a separate statement, make sure you write the two inequalities separated by the word and, because it is everything. It's either this, or it's this and this.